The formula for binomial probability is given by this here. Now for these examples, I'm actually going to be using a calculator to do all the work for me, but if you would like to, you can use this formula to get the exact same answer. It's just already pre-programmed to make life a little bit easier. So we're going to consider an experiment in which 5 offspring peas are generated from 2 parents, each having the green-yellow combination of genes for pod color. For this scenario, we know that the probability of an offspring pea will have a green pod is 0.75. Suppose you want to find the probability that exactly 3 of the 5 offspring peas are green. So let's start off with what we know. There is a finite number of trials, 5. There is a probability of success, 0.75, so it's the same. The options are green, yellow, so only 2 options. And everything is the exact same from beginning to end. The probabilities do not change, and the probability of one does not affect the probability of another. So all 4 conditions are met. So let's start off with what we know. N is 5. We're looking for exactly 3, so x equals 3. P equals 0.75. And though you don't need it for the calculator, if you do want to know what it is, Q is 0.25. So we're going to put this into our calculator. And so when we do that, here, we're going to go to second and vars. And you want to scroll down until you get to binomial PDF. And if you scroll down one more, you see one that says CDF. We want PDF because PDF is for exact amounts, an exact amount. So we're just going to select option 0. So for a TI-83, you have to put in your values. For an 84, it will actually prompt you for what your trials are, your probability, and X specifically. So in here, we actually have to put it in a specific order, and it's going to be parentheses N, comma, P, comma, X. So for ours, we're going to have 5, comma, 0.75, comma, 3. So 5, comma, 0.75, comma, 3. Enter. And when we do that, we're going to get 0.2636. And I'm just going to round it up to 0.2637. So the probability of exactly 3 is 0.2637. 37. Like so. Again, if it's exact, we use binomial PDF. But what if it's not exact? What if there's at least 2 offspring that are green? At least 2. That means 2 or more. Well, what we want to use there is the binomial CDF, but there's a slight problem with that. Binomial CDF only works from a specific number going down. So ours is 2 or more. So we need 2, 3, 4, and 5. So what we have to do is we're going to have to use the complement rule. So what we're going to do is in our binomial CDF up here, we're going to do, again, N, P, and X. We're still going to have 5.75, but now I'm going to not close that, I'm going to put a comma. What I'm going to do is put in what I don't want. What I don't want is 1 or 0. So I'm going to do 1, so it gives me the probability counting down from 1 to 0. So 5, comma, 0.75, comma, 1. And that'll give me 0.015625. Now, like I said before, we're going to do the complement rule. And remember, the complement rule gives us everything else. This is the probability that I do not want. So 0.015625. So if I do 1 minus, I'll get the probability that I do want. So if I do 1 minus this, 0.015625, I'll actually get my answer. So 1 minus, and I can just do second and negative to bring up the previous answer. So I have to type it all in. And I'm going to get 0.984375, which I will round to 0.9844. So if you need something, some specific number or more, we want to do the CDF of what we do not want, which was 1 or less, and then the complement rule to get what we do want. Now what if we want no more than 4 offspring p's, which means we want 4 or less? Well, we're still going to do the same thing here in px, except this time we don't have to do the complement rule. We can go straight to our answer. 5, 0.75, 4, because it will actually count down for us. So again, second in vars, we're going to go to binomial CDF and just plug in our numbers. 5, 0.75, 4. So it'll count down from 4 to 0. And we get 0.76269, which again we can round to 0.7627. So if you have an exact amount, you want to use binomial PDF. But if you have a bunch that you need to collect, either less or more, if it's no more than something, then we can just do the binomial CDF as it is, like we just did right here. But if we have to where we need to get something, some specific number or more, then we do the binomial CDF and then do the complement rule to get what we do need.